All right. So today we're going to be looking at the view part of Django that we saw at the end of the day, where yesterday we started to see, hey, if I go to this URLs py file that's been sitting around here, and is this font size good? Can everyone see this font size okay? Perfect. I can add a path with the URL, and I can give Django a view function that tells it what to do when it gets an HTTP request at this URL. And in this case, all we're doing here is we're basically returning 4, which is the area of a square that we've just hard-coded here. We're going to dive much deeper in this today. We're going to see how to write class-based views to do this. We're going to see how to use the models and the serializers and the model relationships that we learned about yesterday in these view classes or view functions with what's called an API view with Django REST framework, how to hook up URL patterns from not just the URLs py here in the project, but also we'll add it in the app so that each of our apps can have its own routing, right? Because we learned about front-end routing with React. This is routing for our backend. This is creating the different endpoints that our front-end application can hit. We're gonna create an API view to get all of our Pokemon and send it back to the browser. And we're gonna do it for an individual Pokemon as well. And we're gonna do an API view to get all of the different Pokemon moves and send that back to the browser. Part 2 of the lecture, we'll see how to get more complex with URL patterns and also how to write tests to test these API views and stuff in Django. Does anyone have any questions about what we're going to cover today? Okay, cool. And just to warm us up, let's take a look at the code that we already have. And this is the Pokemon and the move code from yesterday. So here we have the Pokemon class that we created. And there's a lot of stuff going on here, right? And these, I think, should be pretty familiar. We've talked about validators. We've seen fields. At this point, I think this should be something that everyone is comfortable with. Really, the big wrinkle that we added was the relationship between the Pokemon model and the move model. But, as I'm looking at this, I don't see a one-to-one field. I don't see a one-to-many field. I don't see a many-to-many field. How did we set up the relationship between the Pokemon model and the move model yesterday? Why don't I see any code here in this Pokemon model code to do that? Eric, yes, sir.
I believe in your move model, you have a reference to Pokemon, and then Pokemon can reference back to moves with a related name.
Yeah, exactly. And let me go ahead and pull that up. And rather than try to rely on the VS Codes thing, which is going to give me all these files I don't want, we'll just do that. And so remember, I have the move app directory, and I have the Pokemon app directory, and the model file for each is inside the app directory. And now I'm going to close this out to give us some more real estate. And Eric, just like you were saying, we define our many-to-many relationship right here on the move model, right? With this many-to-many field. And yeah, remind me again what related name does, Eric?
So the way I think about it is you're essentially telling Pokemon that there is this related model called moves. I don't know if that's the right way to think about it, but that's...
I think that's a great way to think about it. And the thing to remember is, if I'm writing code and I'm in the Django shell, and we'll hop in there real quick. we saw like I could do, my move equals move objects first. I can do my move Pokemon and maybe see all the different Pokemon that use this move. But if I want to go in the other direction, and I have a Pokemon and I want to see the moves that Pokemon has, because I've defined this many field here on the move model, we need this related names so that the Pokemon can do that as well. So that if I do my Poke and we do Pokemon objects first, I can do my Poke moves. Right? And in this case, we're looking at Pikachu. And I think that's the wrong query pattern, but we can see the first move that Pikachu has. Let's see if we can grab this by index. Yeah, I need to look up the query pattern because I wonder if all will do it. In fact, there we go. That's exactly what I was looking for. So we can see all the moves that Pikachu has, right? And that's what this related names does over here, is let us go from the Pokemon to the moves and not just the move to the Pokemon, right? If we're looking at the name of the move and the move is Psychic, we can see the Pokemons that have that move. So these are the models we're going to be working with today as well. And that's the many relationship we put together yesterday. We also made some serializers, right? And can someone else maybe remind me, like, what does this fields property do right here in the Pokemon serializer? Like, what is the effect of me having this list named fields and these different, strings in it? Raven or Daniel, perfect. Thank you, sir.
I believe the fields just so when you call a Pokemon, I believe the fields just displays those specific information. It's sort of like a dunder string method where it just specifies certain I guess like fields of it.
Yeah, exactly. Earl John, yes, sir.
Oh, I was about to say, the fields like specifies the parts or like the name of the columns that we want to turn into a JSON or like to serialize.
Yeah, exactly. If we go to our model, the fields are fields from the model, right? And these are the fields that we're telling the serializer to pay attention to and to ignore everything else. Tim, yes, sir.
So is this like a really easy way to call what you want from the API, what data you want?
Not exactly, no. We're going to
Okay.
use this to build an API. This is more about the back end of our Django code. And actually, to build on that, so actually, Tim, can you remind me, like, if I use the serializer, does it give me JSON? If I do, my, if I import, my Pokemon serializer, and we have to type all this out. And let's use it, right, to maybe serialize my Pokemon. And let me go ahead and clear this. what is this my PokeSer variable? Is this a dictionary? Is it an object? That is it a JSON? What has the serializer given me?
All of the above, almost, depending on how you want to use it.
Yeah, I think that's well put. It's given us an object, right? It's given us an instance of the Pokemon serializer class, but you're absolutely right that we can do a lot of different things with it. And Brandon N, can you remind me, I remember that my PokeSer has this property data, but what does that give me? Does that give me JSON? Does that give me like a dictionary? Does that give me an object?
I believe it gives you a dictionary.
Yes, sir.
Okay.
You're correct. So the serializer gives us a Python dictionary. The serializer does not directly give us JSON, but what we're going to see today is that it's incredibly easy to turn a dictionary or a list into JSON, right? So the serializer can also take JSON, right? If I do, I don't know, new Poke equals Pokemon serializer, data equals, and let's put, I apologize, I shouldn't say it takes JSON because I need to, but I can give it a dictionary. And let's give so this new Pokemon serializer, it makes me call is valid first. We saw this way earlier. So the JSON part happens outside the serializer, but the serializer can take a dictionary and it creates this like Pokemon serializer thing that's more than just a dictionary, like you were saying, Tim. Like, let's go ahead and call this is valid method that it's telling me to call. It says true. And now if I do new Poke data, dict object has no attribute moves. It looks like I might have made things a little complicated because this new Pokemon doesn't have any moves, and maybe this get moves serializer needs a little work, but this is a little bit more of an edge case. And I could modify, like I could modify this to just return an empty list if we need to. What I should be able to do now is new Poke save, and now that serializer has actually interacted with my Pokemon model and saved EV to the database. Right, and now if I should be able to do EV equals, let's say, Pokemon objects get name equals EV. And I already had EV in my database. So Django is telling me that it's returning 2 things, but objects.get only returns 1. But the point is that the serializer was able to save a Pokemon. Right, so this is just a little bit of review kind of what we were looking at yesterday. Now let's see kind of the next piece of the puzzle of we have the model, we have the serializer. How do we go from let's get data into our Django app and send data out of it? Murad, yes, sir.
Are we going to use the association and serialization today?
Yes.
Okay, thank you.
Yeah, absolutely. And in fact, let's talk a bit about what we're going to look at today with RESTful APIs. So this, right, we know the database is way there in the back end, and we kind of see it over here on the left side of this diagram, right? The database is over here. Oh, excuse me. The database is over here. Over here, we've got Django. That's our web server application is Django, and our database is Postgres. all of the Django models that we've been learning about are here in the Django application, right? And the models are a big part of how Django and Postgres talk to each other. And the serializers are also part of the Django application, right? And what we've seen, in fact, is that now with the serializer, and we'll kind of put that here, and I think I'll just put Django, just sort of, we can, if it lets me grab Django. Well, Django's staying where it is. What we've seen is that the serializers, they use the models, right? And so I can, in fact, do an awful lot just with this serializer and not have to interact with the model directly. I can take a dictionary, right? I can take some sort of dict. And I can use the serializer to turn it into a model and save it to my database. I can use the serializer to get a model from my database and turn it into a dictionary. And once I have a dictionary, we turn it into JSON, which is what we're going to be talking about now. And we send it over to the web application. And this RESTful API, this is all part of Django as well. The RESTful API is all of the URLs and the paths and the routes that we create in our Django web server and the pattern that we use, and then our web application talks to them. And I just want to pause and see if folks have any questions.
I do.
Tim, yes, sir.
Yeah, so is serializer the only way to pull models from Postgres, or would you ever use anything else?
There are a lot of ways to get, there's a lot of ways to get data from Postgres, and I should have spoken a little more clearly as well. The models, right, what lives in Postgres is data and tables and rows and columns, right? Postgres has tables, tables have columns, there are rows for each table, and then each column is a string or an integer or so on. The model is an object class that we use to grab that data out of the database and turn it into like an object so we can do all this cool stuff with it in Django. And then the serializer interacts with the model. There's a lot of other ways without using serializers to interact with models, but with Django and Django REST framework that we're learning to use, you're all most of the time going to want to use the serializer.
Perfect, thank you.
Yeah, Murad, yes, sir.
So here in this diagram, you said the serializer would be, yeah, I want to just understand the serializer, like yesterday when you were talking about the views, okay, and the view function and the URL pattern, okay, the serializer, I know the views will be responsible for requesting the models, right? And retrieving the models, and this serializer will be part of the function, view function?
Exactly. And we're gonna, I think it'll be easiest, we're gonna, in about 5 minutes, start writing that code and seeing it in action.
So we'll put this code of the serializer inside the view function?
Yes, and that's what we're gonna do in a couple minutes, exactly.
And okay, one more question. So the
I
view function,
apologize, Murad, I have to
It's
move
okay.
on because I
Yeah,
want to
no
make
problem.
sure that we are able to write some code to get there, but you are on the right track. What you're saying is exactly correct. So and I do apologize. I just want to make sure we have enough time to write out this code. And I think once we see it, it will help illustrate it and make it a lot easier to discuss as well. So this is what we're going to build. And the context here is that all of these applications that we use, Facebook and Instagram, you know, when we open a web browser, when we open a web app, they're making a bunch of HTTP requests over the internet to a server, just like the Django server that we're building now to get data. And this term RESTful API, REST is an acronym. It stands for representational state transfer or something like that. It was some guy's PhD thesis in like 2003. And before this, there sort of wasn't a consistent way that people did stuff over the internet. But it's basically a set of rules about how we design URLs and HTTP requests to be consistent and have a good pattern to let Facebook or Instagram or whatever talk to a server and get all the different kinds of data that they need from it. And this, in this example, what we see here is a couple different things. We see the host name right here. We see this sort of hard-coded thing right here that you always want to put at the beginning, because if I'm Facebook and I decide one day I need to change a lot of my URLs, there might be like thousands of websites that use the old URLs. So what I do is I just change this V1 to V2. And then I change all the other URLs, and all the old websites can continue using the V1 API for like 3 or 4 years. And then eventually we deprecate it, right? So that's the thing about URLs and links. Like if you're a popular big site, I can't just start changing the URLs once they're used, because stuff is going to break. And if we're Facebook, we don't want that to happen. So that's why you'll see REST APIs designed with this string up front and this API/V1. And then over here, we have a resource, right? There might be a posts model in Django that Facebook has. Maybe, maybe not. And so this is part of the pattern of a REST API, where these names in the URLs represent resources that we probably are going to have a model for. There's a lot more to REST API design, but that's sort of the fundamental concept. Our Django server is what handles these HTTP requests at these URL endpoints, right? And then the browser or my phone is waiting for the server to send that response back with JSON data or with an HTML page or whatever it is. And then the browser or the client shows it to the user. Our server may or may not put stuff in the database. It may or may not get information from the database, right? It depends on the code that we write. It's totally up to us. There are conventions around the verbs in HTTP requests. Like we saw yesterday when we talk about a get request, a put request, a post request, a delete request. And the acronym is CRUD. Create, read, update, delete. And as you can see, you know, these are basically all the things that you can do to data in a database. I can create brand new data in my database, a new Pokemon, right? I can read, I can get an existing Pokemon. I can update an existing Pokemon and change their name, or I can delete a Pokemon. And that corresponds to these HTTP verbs. Get is for read requests. Put is for, if this annotation tool will just play along with me. Put is for update. Post, because it comes from like forms and HTML forms, is for create. A post request is for creating something new. And then delete is obviously delete. So this is part of the convention of designing a REST API as well, is that it's not just the URLs, it's also the different HTTP verbs that do different things, right? And then all of a sudden what we have is, with these HTTP requests and these verbs and URLs, kind of an interface to interact with this API that we're writing. So I can write the front end code in my React app, where if, you know, I want the user to be able to add Pokemon or delete Pokemon or whatever, we have a convention for organizing all of that and having the front end talk to the back end in a consistent way. I just had to clear the drawings. So we've talked a lot about like the flow of an HTTP request. And remember that this part here, this is not like an actual server or machine. This is sort of representing the HTTP request going over the internet, and all the URLs are over here, right, in our Django server. And these guys are the same, right? This is the flow, but this is just one server. And what we're going to see today, and you guys got a taste of this with Flask. So, you know, we're getting all of our Pokemon. We send that HTTP GET request from my browser. It goes to Django. You know, we've seen URLs PY. We know we want something maybe like, you know, API/v1/posts, and then maybe, you know, a get all posts view function or something like that. And that's what's going in our URLs PY. Maybe inside there, we're going to use our model or our serializer code, and we're going to do something like return JSON response, you know, posts serializer, and I'll move this somewhere where it's readable. Posts get, or posts objects all. Right, and this is a preview of the code that we're about to write, where we can use that post serializer. We can use that post model to grab all of our posts, pass it into the serializer. The serializer turns it into a dictionary, and this all happens inside our view function. And as a part of that process, Django is going to talk to Postgres, right? Postgres is going to talk back to Django. And then we get the response sent back to the client. So I know this is a lot of red lines on a drawing. I always like to kind of walk through it at a high level, but let's start writing some code and seeing what this looks like. Does that sound good, folks? Okay, awesome. And we're going to do this with our Pokemon. And let me write up a little bit of this code, and then I think that will be a good point for us to pause and do questions. And it looks like, did I break something when I was playing with code earlier? Let's make sure everything is in a good state. Move at models PY, line 25. Let's see what I changed that I shouldn't have changed and fix that very quickly. That should do it. I'll refresh my Django server over here. And let's take a look at what we had yesterday. Right, and so here we're in the Pokédex project directory in the main URLs PY. And we have these URL patterns and these different view functions. Right, and we're doing all of this here. But this is not very well organized. It's all in one spot. We have these different apps. You know, we should be really making view functions in the app directories for our different apps. And as it happens, Python has made an empty views.py file for us. So let's write some code to grab our Pokemon. And excuse me, I just want to make sure I kind of have the guide code that I want pulled up. So we're going to write a view function. I'll just call it all Pokemon. We know that view functions have to take in an HTTP request, even if we're not doing anything with them. And I know that I'm probably going to want to use the Pokemon model. So let's go ahead and import that. And we're probably going to want to use the Pokemon serializer. So let's go ahead and import that. We're also going to need to send back some sort of HTTP response, and Django has a class for us to do that. So this is going to help us turn that dictionary into an HTTP response. So all Pokemon is Pokemon objects, all, right? But what we can actually do is we can use one thing that Django lets us do for querying models is we can, just like with an SQL query, add an order by property. And this will get us all the Pokemon ordered by name. And I want to pass this data into my Pokemon serializer, right? We've seen that I can pass a whole bunch of these model instances into a serializer, and the serializer can handle it. So let's just do that right here. And we saw that we also have to do many equals true when a serializer is accepting many instances of the model that it works with. And so now we have all of our Pokemon serialized, right? We just use the serializer to get a list of dicts with all our Pokemon data ordered by name. Now we need to turn that into JSON and send it back as an HTTP response. So we're going to use the JSON response class that Django gives us from its HTTP library. And this does accept a dictionary, and this does require adding an extra layer to the JSON, and it's going to look like this. And I need to make sure that I use the right name here. So it should look like that. And the JSON response only accepts dictionaries. So just in case this is like a list, we need to wrap this in a dictionary just to be safe. And this is really all the code that we need. Eric, yes, sir.
Do you need the Pokemon key, or could you just drop all Pokemon serial data in there?
What do you mean by Pokemon key?
So you have the Pokemon in quotations. My question is, do you need the key value? Because it takes a dictionary. I was just curious if you needed that or not.
This could be a list, but this needs a dictionary. So in case this is a list, I'm wrapping it in a dictionary.
Okay.
Does that make sense?
Yep. Thanks.
Yeah, for sure. Great question. Because you're correct. It is an extra layer, but that's why we do that. So now that we've written our view function, right, we want to hook it up. We want to hook it up to URLs py. And if we go to the Pokédex project here for this URLs py, we can add a path, and it probably should look something like this: API/v1/Pokemon. But I don't want to point directly to this file. We're going to be adding a lot more stuff, like a lot more Pokemon endpoints to our API. We're going to make another URLs py file here in the Pokemon app in just a moment. So I need to import up here a function called include from the Django URLs standard library. And we're going to say include, and we're going to give this a string, but it's a special string, and it's the name of our Django app, and then .urls. And this is the name of the Python module that Django is going to look for and import here. And I think this will make sense in just a moment, because I'm going to go ahead and make a file in the Pokemon app named URLs py. And let's put that over here so we can have the main URLs py for the whole Django thing on the left, and then the URLs py for our Pokemon app on the right. So I need to import some helpers from the Django standard library. Oh, that is absolutely not what I wanted. And now we do want to import this view function. And now let's write our own URL patterns list, just like we see here. And our path is going to be an empty string, and I'll explain why in a moment. And we're going to use the all Pokemon function that we just wrote, and we're going to give it a name, which lets us refer to it more easily in our code. And this will become more relevant later with testing. And so the full path here is HTTP localhost 8000 / API / v1 / Pokemon / nothing, right? If I put foo here, the full path would become foo. But we don't need foo. We don't want foo. The REST API convention is that /Pokemon is the URL representing the resource of all Pokemon. Right? So does it make sense how these two URL py files connect to each other? Right? And this one points to that one. And so now, fingers crossed, over here, we can do API / v1 / Pokemon. And it looks like, let's see what complaint I'm getting. No module named Pokemon app URLs. Let's restart this. I wonder if this was maybe just Django server needed to be restarted. There we go. Yeah, so Django server is pretty good, right? But settings, py, URLs, py, when you change those, you probably have to kill and restart the server. And now, right, and let's look at this in the network tab, which is, as you know, my favorite thing. We can see that HTTP request goes to this URL. It's a GET request, and this data is sent back. And we can do this in Thunder Client as well, right? If I open up Thunder Client and I do, let's just copy this whole URL. I'm going to go ahead and close this out to give us a little more real estate. Right, it doesn't matter what the client is, if it's the browser or the Thunder client or my phone or my grandmother. If we send a properly formatted HTTP request to the right URL with the right HTTP verb, we get a response. And here in the body of our HTTP response, we see all of our data. So this is, I think, a great pause point to check in and see what's on people's minds and what questions people have. Murad, yes, sir.
Yeah, I didn't understand. Why did we make another URL in the application? Why? Because the first one that you created in the beginning in the project folder, it was working, right? And yeah, it was mapping to the view. But why did we create another one?
Yeah, absolutely. Because what we're going to do over time is we're going to, we might have more paths here. Like we might have, I'm trying to think of another path off the top of my head that we can add here as an example.
Okay, if we added more paths, why you didn't add it to the the one already created by default in the project folder.
Yeah. Let's see. With Pokemon, we have the moves in a separate app. I don't know. Maybe like battles, and this would be Pokemon/battles. And what we're also going to do over here is we have moves, right? And so over here, we're going to have moves app and URLs. And so this is a very simple introduction, but as your applications get bigger, you're going to have a whole lot of endpoints. So this way for each app, it has a URLs PY that you can fill up with stuff. And then you just include this here. And the main URL patterns for the project should really just look like this. It should really just be pointing to URLs PY and other files. So that it's for organizational reasons.
Ah,
Yeah,
okay. So
exactly.
so yeah, okay, I got. So the URL in the project, that would be like the reference to all the URLs for each application.
Yeah, exactly. And in fact,
Uh,
let's go ahead and let's build that right now. And let me get some help from all of you in doing this. Let's go ahead and I think what let's see how we're doing on time. We're almost there. I apologize. Actually, we're not going to go to the moves yet. I'm sorry, I got a little ahead of myself. We're going to do a little refactoring of what we just built. Because there's an even better way that we can do this. But Maura, that's exactly right. That's where we're going, where this is going to be sort of more of a container.
yeah, that makes sense. Yeah. Okay. So okay.
Totally.
That's why include. Also include all the URLs that is related to this application, Pokemon application, and this URL will be in file inside the application in this application, and each application will do the same thing. So in the
Exactly.
main one, in the main URL, will make include, and the path it will map to the URL for the new application. Okay, I got it. That makes sense. Thank you.
Exactly. Absolutely. And what we're going to see now is we're actually going to use Django REST framework and something called an API view, so that we don't have, we're not going to do this as a function. We're going to do this as a class. And it's going to become more powerful and more useful because this is like a GET request, right? But then if we wanted to, you know, maybe like post, we would need def create Pokemon. And that would only be for post requests, and for delete, we'd need a def delete Pokemon function, and we'd have to like add if statements inside here to tell it to look at a post or delete or whatever. So instead of writing a bunch of these different separate functions, let's make them as methods on one class, and we'll see how Django REST framework enables us to do that and make it easier. Because the goal is there's only the one URL, but we change the verb. So the good news is this is actually really straightforward. I'm just going to go ahead and import from Django REST framework views, the API view class. And it looks like I must have there we go. I don't know why VS Code didn't want to comply there. Django REST framework also has a response class that we can use instead of the JSON response. And let me fix my typo there. And so let's refactor this into a class. We'll leave this here just for the moment, but we'll do class all Pokemon, and it's going to inherit from API view. let's make this a method inside this class. Like every class method, the first argument has to be self, but it still has to accept this request class. Let's take a quick look inside the source code at this API view class and just see a little bit of what it does and what it gives us. We're not going to go too deep into this, but we see there's this method as view. It's actually going to return a function for us. We can see, we can actually like set the different HTTP verbs if some HTTP methods aren't allowed, stuff with authentication that we'll learn about later. So the Django REST Framework API view class offers a lot of really, really useful stuff. And again, the docs are where you're going to want to spend more time. And as you can sort of see here, we're not there yet, but once we build out other methods, we can tell our class like what HTTP verb to use for what method. But for now, we can keep this relatively straightforward. I do need to change this name to get, and then that way Django REST Framework will know this is for an HTTP GET request, and it will take care of that automatically for me. So now that I've done this, I do have to make a change in URLs PY in the app. If we go over here, first of all, we're no longer importing that. We're importing this all Pokemon class. And I have to call this function as view, which transforms the instance of that class into something that Django can use and a function that Django expects. And I want to double check that I haven't done anything wrong along the way here and that everything is still working. And now we're looking good. So let's do this again now for moves, right? Let's make an all moves API view, and let's hook it up with routing. So can someone maybe walk me through the first step of that? Earl John, yes, sir.
Can you repeat the question again?
Yeah. So we've hooked up this routing for a Pokemon. So I now have an endpoint where I have API/v1/Pokemon, and I get all my Pokemon. I want to be able to do the same thing with moves. So I'll get us started off with API/v1/moves, and we'll do include moves app.urls. What's the next thing I should do to make this endpoint real so that I don't get an error? Murad, yes, sir.
Create the view.
Yeah, exactly. I think that's a great place to start. Let's go to the moves app. We have views.py. Can someone else remind me, what do I need to import to use a Django API view? Earl John, yes, sir.
REST framework dot views.
Yeah, exactly. I need to import API view. And what's the other thing I need to import, Earl John? The API view class, and then there's something else that I need.
It's a REST framework dot, I think, response, and then import response.
Yeah, exactly. I need the API view class, and I need the JSON REST framework response object. And I know I probably want to create this class, and let's call it all moves. We know it needs to inherit from the API view. And maybe like, can someone who hasn't participated yet remind me, what do I have to do? What do I have to do next? Yeah, I see a couple of hands up. Gary, yes, sir.
The get method.
Yeah, exactly. And what are the two arguments that this get method takes?
It's self and is it the view?
Close. It's, yeah, it's the HTTP request object. And it needs to take both, even though we're not using request, it will throw an error. Actually, I think I'm just going to run down the list here. Dustin, now that we've created this get method, how do I get all the moves from my database and serialize them? Dustin, can you hear me?
I can hear. Yeah, that's a good question. I'm not sure exactly how it's done yet.
No worries, man. We're learning it today. Who do you want to phone?
Looks like
Sort of in the
Earljan's
phone a friend.
able to help. Yeah, Earljan, you able to help?
Yeah, first, we would need to import the serialization, and then we
Yep.
can create a variable underneath, so like move equals to move serializer, and then inside that is the would be the move dot objects dot ordered by, and then is it like the name was the
We can order by whatever you want.
yeah, we can just order it by name, and then we can say many equals to true,
And why do we have to say many equals true?
so that it can take in more values or more objects.
Yeah, exactly. And Earljan, do you want to take us home for the last part of this, or for this method, or hand it off?
I can try. And then we can do a if moves is valid, and then we will do a, what do you call this one?
Close. Is valid is for if we need to validate data before we use our serializer to save it to the database. We're getting the data from the database already. We know it's good. We want to send it back as an HTTP response.
Okay, so we can just do a return response, and then inside the response is the moves.
Yes, exactly. And in fact, with the Django REST framework response class, we don't have to wrap this in a dictionary. It will figure that out for us, and we can just do moves.data. And Murad, did you have a question, or would you like to take us on the next step of the journey?
I think you answered it, because we used to say we say like that's HTTP response or that JSON response, but you said you don't need to do that, right?
Exactly. Exactly. Now that we're using Django REST framework and the API view class, we can use its response class. And actually, let's take a quick look at this code. And so we see it probably uses Django's HTTP response class under the hood. It does a lot of work for us to render it into arbitrary media types and does a lot of the work for us in essence. I don't want to walk through this code too much. I haven't looked at this code that much before, but we can see that there's a bunch going on here. In fact, we see it's importing stuff not from Django, but from Python's HTTP client library. It's importing that response class and using that. And Murad, actually, now that we have this all moves class, how can I hook it up with some paths and routing to my URLs PY so that this endpoint will work? What's my next step?
In the URL, we have to define the path, or you already did that?
So we've got this right here.
Yeah,
in the project file, but I don't have a URLs PY file at all here in the move app.
Okay, we're gonna create the URL inside inside the application. Yeah,
exactly.
And then we're gonna define the pattern, the URL pattern.
Yep.
Equal list, yeah, and then the define the path, and pass as a second argument the view function or the view class here.
Yep, and let me go ahead and import that from our views. Let's
Import views, yeah.
all moves. Let me also just quickly import from the Django. Let me check. I always forget where to import this from. From Django URLs, import class path. So from Django URLs, import path. And now, just like you were saying, I can do all moves. And what's the one thing I need to do here with the all moves class?
As a view.
Yeah, exactly. Awesome. Thank you, sir.
Thank you, sir.
And let's see how we are doing. And it looks like there may be something I forgot, though the thing I forgot may simply be restarting the server because we've changed the URLs PY. It looks like I may have a typo in my code because it says no module named moves app. So let's go to the main URLs PY. And if I look over here, it's indeed move app. So this is, I think, a really easy mistake to make. Let's see if that resolves the issue. Looks like something, it's still not happy about something. Let's see what it is. Oh, there we go. Actually, now it's working. And Django REST framework gives us this really nice visual display of our API call and the response and the JSON data. And we see that it's a GET request. And so now we have Django REST framework up and working. So this is why serializers are awesome, right? I have a list of all my moves formatted exactly how I want them. And yes, there's a lot of moving parts with understanding model relationships and serializers, but the plus is one line of code, 2 lines of code. Now, obviously, there's more code over here, but we get to use this all over the place, right? So I just want to check in and see how folks are feeling about this. Maybe get like some thumbs up, some thumbs downs, some hands in the middle. How are we feeling about this stuff? So what are, I see some thumbs up, I see some hands in the middle. For those of you kind of with, you know, like not quite thumbs up, but maybe not quite thumbs down, what are maybe some of the things that are either a little more complex or newer or that you have questions about? Murad, yes, sir.
So just the whole process to create the view, the class first, right? The view. And then
I apologize. I right now I don't want to do a full review because I do want to, there's one more thing I want to show folks and then take a break so we can have the hour to work on stuff. But if there's a specific step that you want to look at, then we can definitely take a quick look at that now. But actually, you do raise a good point. We should maybe just walk through the whole process once. Actually, I think that's a good call. So let me actually go ahead and do that, and that way I can also just move the screen as we go. So just to kind of recap the whole process, and actually, Murad, do you want to take us through it, starting maybe with the URLs PY right here?
I was going to say in general, like creating, like if we have more than one application now, okay, we start creating another URL file inside the application that has more than endpoint.
Yep.
And we create the view for this application.
Yep.
And inside this view, we're gonna create the class view.
Yep.
And then we're gonna map, and then we're gonna map the route, create the route or the, yeah.
Yep, and I should update that. Yep, exactly. We create the route here in the URLs PY for the app. And
yeah,
then
and will
we
be
have to hook up-
included inside the big one. Yeah, the project, the whole URL one, the main one.
Exactly. That was awesome. And you hit the nail on the head. The one last thing I want to show folks, and then we'll break and we'll have just a little under an hour to get some hands-on time with this, is making an endpoint to just get one Pokemon. And let's take a look at what that looks like, and let's make another API view class to do that. And I think that will help illustrate some of this as well. And give me just one moment to get kind of my ducks in a row. And actually, Maura, I think this goes to a question you raised earlier of why are we organizing things this way? So I'm going to write the API view function first, and then we'll see how to hook it up. And let me go to the Pokemon view. And we're going to make another class. And this is for, right, CRUD, right? Create, read, update, delete for an individual Pokemon. And as always, we need to inherit API view. And we're only going to write the get method. For reading, we're not going to worry about the other ones. But let's go ahead and write this and see what this looks like. And let me kind of hide this so we don't have to look at it while we're writing this code. So how do I know what Pokemon I want to get? I either need the Pokemon's name or its ID. So I'm going to go ahead and just, let's say ID, and we'll put that there. Let's say that the ID could be a string for the name, or it could be the actual ID. So let's add an if statement. Our code is going to end up doing something like this. Actually, I apologize. Let's save that for later. I don't want to get into, we're not going to worry about the ID as a name. We'll tackle that later. So for now, let's assume ID is, the ID int, to do, handle if ID is the name, if it's a string. So I'm going to go ahead and do Pokemon objects get ID equals ID. I know I want to put this in my Pokemon serializer, right? This gets me the individual Pokemon. And here we'll just do it. I'll kind of write it out, all the steps. Right, we can do this in one line, but for learning purposes, I'm going to break it down into two. We know we're only dealing with one Pokemon here. And now we can return. And actually, I should have updated this as well, because now that we are using Django REST framework, as you guys pointed out, we don't need this sort of dictionary wrapping it because its response class will do that for us. I can do return response, poke serialize.data. Right, and now the question is, how do I get this ID in there so that we get the right Pokemon? Over here, we have to add a new path for this because I need a different URL so that Django can figure these things out. And we're going to put the Pokemon ID in the URL. And our full path is going to look like this. where :ID, that's a placeholder for an actual ID value. And this is what we saw how to do at the end of class yesterday. And it would help if I imported my new view function, my new view class. Let's do that right here. And so this is why it's nice to kind of start to put all of these URL patterns for each app in a separate URLs PY, because as I build this up more and more, everything is in one spot. And if it's useful, I don't know if it's useful. Do folks want to see a third split with the main URLs PY, or is that not so useful? Sure, why not? Let's do one more split. And over here, we'll grab URLs PY from the main thing. So I've added a lot of, in some ways, I think this stuff might make it a little more confusing to read at this point. So I'm gonna get rid of it so our code's a little cleaner. And let's kind of just line everything up. And also now let's see if this actually works. And I might have to kill and restart the server. And it looks like I have some sort of mistake in here, not found API/v1/Pokemon/1. Earl John, yes, sir.
I think you have to turn it into a string. So like instead of the int, it has to be like an str, since it when it goes to the class, it will like make it into a string. Like in the path, line 8.
Maybe, I'm not sure. Let's add a print statement here. Going to get Pokemon for ID, right? If we see this print statement, that tells us that we've gotten this far and the code is good. If we don't, it tells me that the problem is prior to this point, sort of like what you're saying. The fact that maybe you're correct, though I would have thought that we're fine. I feel like that's what we had yesterday, right? With the squares and the triangles and stuff. Yeah, I don't think that's the issue, because what this does right here is everything comes in as a string in the URL. And this tells Django to grab this value and cast it to an int. I think I just must have a name wrong somewhere. Or I wonder if the ordering of this could be the issue, because that is also sometimes an issue. Oh, well, let's see what we got wrong here, because we got awfully close. So I didn't mean to go into debugging mode, but my debugging mode is like get a Pokemon, right? Because I just want to figure out right now if I have a typo or if I have a bigger issue. So I'm just going to start hard coding stuff until everything works. And then I'll start changing things one step at a time. And let's change this to get a Pokemon. Right? Okay. So this tells me I'm doing something silly because this is pretty simple and it should be working, but it's not. So I feel like there's something relatively simple with the pathing stuff, and it is probably a typo or something somewhere that is escaping me at the moment. I don't know if I don't think that adding the name really should make a difference. Yeah, it looks like I think I might have a slash wrong somewhere. And I suspect it might be because I don't have slashes at the end of these. Yeah, so that I think actually was the issue. I think we're actually making progress now because we're actually making a GET request and getting a response. And we're getting a totally different kind of error. And we're seeing this print message going to get Pokemon for ID 0. Okay, so that wasn't my intent, but this actually is really good to see because it's a very easy mistake to make. So the problem was because I didn't have this closing slash here and here. If I go to the URLs PY for Pokemon, it didn't really matter for this first path that we have because there's nothing here, right? But when Django was building up this one, I needed to either put the slash here or put it there so there's a slash in between each step so it matches what I was actually putting in the URL. And that's not what I had. I didn't have that slash, so it was literally a bad path. So the key thing here to remember is here in the main project URLs PY, just always stick a slash at the end of each path, and that will basically resolve the issue. And now let's see if we kind of started adding this stuff back in. How we do in terms of getting the code. It looks like there might be a little bit of an issue with the querying, but we can fix that and go from there. Unexpected keyword ID is fine because we took that out. So let's add that back in. And actually, now this is working. And the other issue here is that it looks like Postgres does not use 0 as an ID for a Pokemon. So the very first Pokemon, Pikachu, has an ID of 1. So that was a little bit of a detour, but there was actually some good debugging in there. And we kind of got to see, I think, a common Django issue. Just to reiterate, make sure you have a slash at the end of this. And as you guys saw, like a good tactic when you're debugging is basically start getting rid of things that might be wrong until you have something dirt simple that you know is right, and then add stuff in a piece at a time, right? Because then you can kind of, I was kind of having a hard time seeing what was in front of my face, right? And that kind of helps us debug the issue. And so now we can get an individual Pokemon, and if we go for 2, we see that we get Bulbasaur, and if we go for 3, we get Charmander. Do folks have any questions or things we want to review with this before we break and have some work time to work on this ourselves? Okay, awesome. Thunder Client is also your friend when working on this stuff. In a lot of ways, that's actually a faster debugging loop for something like this. As I'm like working on my code to just have this here, you know, and hit this and see all the bad data. But Django REST Framework actually gives us very nice error messages. So they're both good tools to have. And just to kind of do the summary that I wanted to, let's do a split here, and let's look at the other URLs PY, and we can kind of see how these two get built up. Right, where this and this get combined. And so we end up with API v1 Pokemon /1 or 2 or 3. And Django takes that string. And Earl John, you're correct that there are and there can be issues with that, but everything in the URL is a string, and what Django is doing there is casting it into an int for us. All right. So the assignment to get going on during this sort of work time is continuing with the school API, school API 6, I believe. Let me make sure I am indeed looking at the right spot for everything. And if we look at the existing code that you have, which is always a good idea, we see there's 3 different apps here. And we see, in fact, there's already a lot of existing model code for the student model. And in fact, there's already some existing student serializer code, as there are for some other models as well. So you have serializers, you have models, and now your task is to build an API endpoint, right? So I would focus on what we've been going over just now to create the API view functions and hook it up to the URL routing and URL patterns and use the existing models and serializers. I think it should get you pretty darn close to the format that we need here. But then once you have everything working, if you need to, you can tweak the serializers. And same for subjects and so on and so forth. And we also have some tests. Let me go ahead and stop the recording, and then we can break and dive in. So, you know, while the models and associations, I think, are that is one of the most challenging bits. Hopefully, the stuff that we're going over today, I think, is much more approachable. We covered a lot of ground in the first part. We built our own view function. We then saw how to use class-based views, API views from Django REST framework instead of view functions, and how to link URL patterns from projects to apps. And we made an all Pokemon view and an individual a Pokemon view and an all moves view function. What we're going to look at now is we're going to spend a little bit of time looking at how to make our own URL pattern converters so that in that URL pattern, say for our Pokemon, we can accept either an ID integer or a name string. And we're going to spend some time learning how to write tests for views, because testing is extremely important. It helps, especially with the more complex stuff, like say serializers or associations. The tests can give you confidence when you're writing code or modifying it. And as always, the assessment itself will have a lot of tests. So the best way to understand a test is to read it, and the best way to be able to read a test is to write some. Does anyone have questions about sort of part 2 of the lecture? Okay, awesome. So, you know, where we left off was, and let me close out some of these things that we don't need, and we'll go to the URLs PY for Pokemon, where we have a path to get an individual Pokemon. And fingers crossed, things are still working good over here. There's a couple issues with this, right? You know, one issue we ran into is that if I give an ID of a Pokemon that doesn't exist, I get this error because there is no Pokemon with ID 0 in our database. This actually has a very easy fix. Before we dive into sort of the custom URL pattern converter stuff, let's make one tweak to our view code. I'm going to hop over here to all to a Pokemon. And here, instead of Pokemon objects.getID to get my Pokemon, I'm going to use a function that we get from, I believe it is, let me double check if it's coming from Django or Django REST framework so that I can import it from the right spot. Yeah, and indeed it comes from Django because this is such a useful thing that Django just has it built in. So Django has a shortcuts module, which I don't know about the name of that, but it has this incredibly useful function called get object or 404. And note there's also get list or 404. So maybe we if we wanted, we could use that for other stuff. But for this, it does exactly what it sounds like. It gets an object from the database, or it returns an HTTP response with a 404 error. And so instead of seeing this message that we see over on the right side of the screen right now, right? Instead of seeing that, we'll see a 404 error message like not found, which, wow, that's not ideal. That means the application doesn't actually break and we're giving the user and our client application useful information. So let me go ahead and let's make this change now. And right over here, instead of the Pokemon.objects, right, we had Pokemon objects get ID equals ID. And the problem with this was, what if ID doesn't exist? We don't want to break the app, but we do want to return an error message, right? So instead of this line of code, let's do poke equals get object or 404. And this function takes two arguments. The first one is the name of the model that it's going to look for, which is Pokemon. And the second is we do have to pass the ID that we're looking for. And let me make sure that I get this syntax right when we use it. And right now, what we're looking for is ID. So we have to pass a named argument that looks, I believe, like that. So let's test this out and see if this works. And indeed, now for this Pokemon that doesn't exist, what we get is an HTTP 404 not found response, right? Which is a valid HTTP response. Our application has not broken. The server code has not broken. We're just telling the client, hey, this thing that you want doesn't exist. So this get object or 404 method is one of your best friends, right? And we can still get our Pokemon and so on and so forth. So this should look familiar. We talked about this a little yesterday, this idea of posts, and we're learning more about URL params like we see right there. This is very similar to what we're doing with our Pokemon ID, right? But there's this scenario where, maybe I want an integer ID or a string name. I want to be able to get my Pokemon by name or ID. So how can we accomplish this? The challenge is in URLs PY. Because if I hop over here to the URLs PY for my Pokemon app, well, I can do this, right? And I can do this. But these are the same path, and Django will just use the first one here, or I'd have to somehow give it like a different route, like Pokemon name. And in this case, that's not what I want to do. What I really want is something that looks like this. String or int that would handle either one. This is called a converter in Django, and we can actually write our own. So let's go ahead and write our own custom converter to do this for us. And I apologize, I'm just getting myself oriented here, and then we will in fact go ahead and do exactly that. So as with everything, this is going to go in our Pokemon app because it's specific to this app. And we need to make a file named converters.py. And now, you know, as to your point, Brandon, we're about to see even more magic happen. And in fact, just to kind of show you all where this magic is coming from, if we take a look at the Django docs, so there's actually some very interesting information here about how Django processes a request and goes through a whole process and with URL patterns and stuff. But the relevant bit is what Django calls path converters, which is what we've been using here, right? To grab a part of a URL or a part of a path and cast it and validate that it's a string or an int and so on. And we can actually create a custom converter, and we have to write a class, and then we do what's called registering it, which is a common pattern with these frameworks like Django, where you write all these classes and you have to tell Django it exists, and that's what registering is. And we have to basically follow this format. And if we dug in the Django source code, we could see the why of all of this. But the reality is that this is what Django is looking for the converter class because of how it uses the code. So this is the format that we have to follow. So we are going to write our own, and we are going to call it class int or string converter. We need to add this class attribute regex. We're not going to use it, but Django will. And for our int or string converter, we are going to accept integers between 0 and 9. But we also will accept letters, lowercase or uppercase, right? So this regex Django will use to check the part of the path that we want to do this conversion. Django requires us to write a method named toPython, where we pass in self, and then Python, when it calls this, will pass in the value. What we're going to do is we're going to tell Django, hey, if this thing is a digit, if it's a number, cast it to an int and return it. Otherwise, cast it to a string and return it. We're not going to use this now, but Django also sometimes uses this going in the other direction when turning a value into a URL. So when writing a custom converter, we also have to write a toURL method to make Django happy. And that can look just like this. And since this is for turning a value into part of a URL, we want to cast it into a string. So this is my custom converter. I do now have to register it. And I believe we can do this in the URLs PY for the Pokemon app. Brandon, yes, sir.
We misspelled self on line 10.
Oh, thank you so much. That is a good one to fix. Much appreciated. So just to reiterate, there is a lot of magic happening with this. And that just is more and more the case over time. And we're about to use this register converter function here. If we dug through the Django source code, we would understand exactly why this needs to be written the way it is. It's not actually magic, but there's just a whole lot of layers, right? So we need this class attribute named regex that gives our converter the rules of what is or is not valid. We need this method named toPython that accepts as an argument the value from the URL. And we get to do whatever we want in here, but we need to return the value, and we want to cast it to the appropriate thing. And we need to write a toURL so that Django can use this in the other direction sometimes when constructing a URL. And it looks like I was playing around with the URLs PY. So there may be some other stuff that we need to do. But now in here, we need to, first of all, import the converter that we just wrote. So let's go ahead and import that from converters. And from Django, we also need to import, and this comes from Django URLs, the register converter function. And then we can call register converter right here and use our custom converter. And we should just put this first in our code before we even get to the URL patterns, because we then want to use it in here. And if we take a quick look at this register converter function, there's not a ton of information here, but it is interesting to see Django is not doing anything crazy fancy here. They just have a dictionary that they're adding all of these class names to for all the different converter classes, right? And there's other stuff that's going on here under the hood, but the more you dig into this stuff, it's not actually magic, though it certainly feels like it because there's so many layers to it. Right, but I think that's why sometimes it's good, you know, just to look and see, and we can see here's an int converter, and they follow the same format and so on. And so somewhere in the Django code, we can find where these are used, and we can see how Django's actually using this regex class attribute. So now we've registered our converter. There is now more Django magic in that the name, when we use it here, will be int or string str, and note how that conforms to this name right here in camel case as per the Python convention. We should probably update these to be camel case, but that's a task for another day. So Django does have a lot of magic, which some people like and some people don't like, but this is one of those magical pieces. So first off, I just want to test and see if this works. It looks like I missed a step with register converter. It's telling me I need to pass another argument type name. And in fact, I apologize. This is better. I jumped the gun a bit. This isn't magic after all. At the end of the day, we get to pass this in as an argument. I got a little tunnel vision there, right? So if I wanted to, I could change this to, you know, my int string converter, and that would be the name of it. And then we could use that same name right here. But I think keeping them the same is much better for purposes of clarity and sanity and code readability. And so now the server runs and we don't have any errors, and let's just test that our code still works. So we're still able to get a Pokemon back, which is great. We haven't written any code to actually do anything with when we pass a name, right? So that's our next step now, is let's go to the view function in our class view for the Pokemon. And I'm going to move this off to the side to clear a little space. And now we need to handle this to do from before, handle if the ID is the name, if it's a string. So luckily, this is pretty straightforward. And I'll get rid of this old code now that we're done with that. And what we can do is if type ID equals integer, then we get the Pokemon like that. Otherwise, we can do Poke equals get object or for Pokemon, and we can do name equals ID, right? Which feels a little weird. I think this will work with get object or 404, that we can use the name. ID is actually Pokemon name. And let's see how we do. And now we're able to get Pikachu. We're able to get an ID of 1. And I'm able to get Bulbasaur, if I spell his name right, which I didn't, but we didn't throw an error. Maybe Pikachu is the only Pokemon actually in our database right now from yesterday and stuff. Though it looks like we're actually not even getting Pikachu either. So let's do a bit of debugging to see what's going on here, because it did seem like it works fine with IDs. Right, this is still working well. I wonder if oh, it's not the name. So let's add a little bit of debugging, right, and just see what happens. Print Pokemon ID is string. Pokemon is, let's just see where we get with that, if that shows us maybe where I went wrong. So this is a good sign right here. If you all can see, I'm seeing the print statement that I wrote out. So that tells me that this line of code is good, and that the problem is with this line of code. I'm wondering now if I jump the gun and I'm not doing something right with get object or 404. So to test that out, what I'm going to do is I'm going to print Poke object is, right? And let's see. Well, in fact, this must be failing because we're getting the 404 back. So let's change this to Pokemon objects get name equals ID. And let's see how we do with this. And I wonder if the issue here is about like lowercasing or uppercasing the Pokemon name. I suspect it is because we've enforced that all these Pokemon names have to start with an uppercase letter. And that's how they are in our database. So let's try uppercasing the first letter of the name. And we can do that with the Python string function title that should uppercase the first letter of the name. And let's see if this gets us any closer. And now we've got Pokemon, right? And in fact, let's see if that original code let's see if this indeed does work. Yeah, so this is one of the challenges with Pokemon names. This is actually a good argument for storing stuff in the database in all lowercase whenever possible, and like using this on the way out to format the Pokemon name. Like it's great that we validate, you know, but if I was designing the data model, I would make sure everything is in lowercase and we capitalize the first letter of the first word on the way out when we send it back to the user. But now we've got this working. We went through a good debugging process there, and we're able to get different Pokemon both by name and ID successfully. So I just want to pause and check in and see if folks have kind of any questions about building this custom converter function, and then this logic that we've added to make our get endpoint for a Pokemon more powerful. Are we feeling pretty good about this? So? Okay, I do want to move on to make sure that we cover tests. Let's just do a quick recap of what we've done. We've written a custom converter class called interString converter. We had to follow a particular format that Django has. But this is what checks if whatever we put in here is indeed a number or a string. So I can't like do something like this, right? I don't want that with something that's actually invalid. We register that converter class, we give it a name, we use it here in our URL path. And then here in our view code, because we now accept these two different kinds of IDs, we have to write some conditional logic to handle them correctly. And this is all about, you know, names are stored with first letter capitalized in DB. Right, in the database, it's Pikachu. In the URL, I get lowercase Pikachu, and that's what was causing the error. This title function, I'm not sure if that comes from Django or Python, but it capitalizes the first letter of a string. And since we know that's our format for these names, now we can correctly find something by its name. Let's look at how to write some tests for this stuff. We've written a lot of API endpoints. It's time now to write some tests for them to help give us clarity and certainty about them. We want to create a tests directory inside the Pokemon app. So I'm going to go ahead and do that now. And then we're going to add our tests inside there. And right now we have this test file from the other day where we were testing our models. Just creating a Pokemon and checking the validation logic for the Pokemon name. Let's rename this and move it inside of this tests directory. So I'm going to kill my server and I'm going to do, I'll just use the move command to move Pokemon app tests into Pokemon app tests test models.py. Right, and so now what we're also going to do is we're going to make a file named test views. And here's where we're going to test our Pokemon views. There's a couple things we'll need to import to get this going. We'll need to import test case. We also need to import from Django test a class called client that simulates, it's not a full-on browser, but it's sort of like Thunder client or curl on the command line to send HTTP requests to our Django server. We're going to import a helper from Django.urls called reverse. And we're going to fill this out in a bit, but we're going to write a class and it's going to be called test views. It's going to inherit from the test case class. And for the moment here, I'm just going to put pass. And we have to go ahead and flesh this out and make this real. What we need is we need some data, right? Because we can write tests, but if we don't have valid data to compare it against, then it's not very useful. So there's two ways to get data. We can actually grab it from the browser and API calls and stick it in some Python files. And we can also get it from fixtures by dumping data from the database. So let's do a bit of both. We need to make a couple fixtures and we're going to grab some answer data. So I need to very quickly remind myself of the format for dumping data. And let me go ahead and change this to what we want. And then we'll talk through it before we run it. And dump data, just like migrate or make migrations, is one of these Python sort of Django admin functions that we can run. I think we already have some Pokemon data. So before I run this, I want to check what we have in here. So we have Pikachu and we have Bulbasaur. I'm just going to run this dump data into Pokemon data2.json. And remember, this is going to dump everything currently in our database into this JSON file in this directory in fixtures. And so we still have Pikachu and Bulbasaur, but now we also have Charmander and Squirtle and Blastoise and Eevee. And we have 2 EVs, which to be honest is a bit of a problem. So I'm just going to delete the second EV from this fixture file. And I kind of like this one better than the other one. So let's just delete our old one and just rename this. Right, and let's do this for moves data as well, because that might be useful. I don't have a fixture directory here for moves. So let's make a directory named fixtures under moves. And I'm just gonna take the same command I did before, make a couple of changes. The file is gonna be named moves data. It's gonna go in the fixtures directory in the moves app directory. And it's not the Pokemon model, but the moves model and the moves app. And I'm also going to quickly make sure that move is singular and not plural. So let's fix that right now. And I think it's the same thing with the move app. I remember making that mistake before. No such file or directory. And that's because I changed, I have moves plural instead of singular there as well. And so now we've dumped our moves data and we have 1 or 2 moves here as well. So now that we have these fixtures, we can go ahead and we can use them in our test. And let me go ahead and close out these files that we no longer really need. We're going to need to grab a little bit more data, but this is a pretty good start. So there's a couple things we need to do for setup stuff that are a little bit of Django magic. We're going to do a little Django magic so the test uses our fixture files. Here's a question. When you run the tests, is Django interacting with your Pokédex DB in Postgres? And this isn't something we've talked about. Anyone have a guess? Yes or no? So the answer is no, because that database would have our real data for our live application, right? And if the test is adding things and deleting things and changing things, that could be a real problem. Plus, the data in the real live application is constantly changing. So when Django runs its tests, it actually creates a new database in Postgres named like test underscore Pokédex DB or something like that. And everything for the whole test run happens inside there. However, that means that that database by default is empty unless we tell Django to load some fixtures. And that's what we're about to do right now. And every time you run the tests, that command line command to run all the tests, it creates a new test database and runs the whole thing from scratch and then deletes it. I believe it deletes it when it's done. So we need this class attribute fixtures that's going to be a list, and we can just give it our JSON files here. And I actually may need to put the moves fixtures in the Pokemon at fixtures directory as well, because this test is living in the Pokemon directory. So let me actually confirm and make sure that I have that in the right spot. I might just have to do a little bit of copying a file. I think we're okay. I think what Django will do is it will look in all the fixture directories in all of the different apps, which again is, I totally admit, a little bit magical. If we run into that error though, we'll know what to do. But I believe this should set stuff up for us. So we now have some fixtures. There's also stuff that we want to do right at the beginning of each individual test. And every single test library has a special function for this. It's usually called setup or something similar. And for the unit test framework, it's also called setup. And what we need to do is we need to create a client program. And this is going to be what actually sends the HTTP requests to our Django app, right? We're not using a browser like with Cypress, but we're using some Python program that sends HTTP requests. And that's what this client program is. And so we're going to need a new one at the beginning of every test. So let's put it in the setup function so we only have to do it once. There's just a little bit more work we have to do, in that it'd be useful to know like what is good data and what is bad data and what that looks like. So let's use Thunder Client to get some data, and let's put it in a file named answers.py. So I'm going to create a file here named answers.py. And this is going to like hold answer data to use for our tests. And, you know, we have these two endpoints, and in fact, we can see them. Actually, if we go to probably views is the best place to look at it, right? We have all Pokemon, so we should write a test for this and to test this URL path as well. And we have an individual Pokemon. So I'm going to go ahead and I'm going to open up Thunder Client. And we're going to make an HTTP GET request. And it's going to be to get Pikachu, to get an individual Pokemon. And it would help if my server was running. So we're going to run the server again, and we're going to try that request one more time. And so now we have some very nice looking JSON, which is exactly what we need. I do want to be a little careful with the formatting of the response. And let's see if we can maybe, because I don't want like new lines and stuff in here, like invisible characters that aren't in the code itself. So I think what I'm actually going to do is use the browser instead of Thunder Client, because this text data is going to be what we compare stuff against in our tests. And as you all have seen, you know, if you have a single character off, then it can really screw stuff up. And this is nicely formatted with indentation and new lines for us humans to read. But I don't really trust that that's exactly the response being sent back. Like, I don't know if it's inserting like new line characters. So I want to look at the raw response. And there's think what I'm actually going to do is I'm just going to do this on the command line because I'm not quite familiar enough with curl to be completely honest, or with Thunder Client. There probably is a way to do it very nicely. I'm just going to use this program curl that makes an HTTP request on the command line. That's what I want, right? There's definitely no new lines here. And we're just going to assign this to a variable, a Pokemon. And now we have a string. I do have to do a little work, I think. We may actually be able to use this as a dictionary as I'm building this out and I'm looking at this. But this is a good starting point anyway, just so that we have some clean data. And as we build out the test, we can see if it works better for us to have this as a string or a dictionary. But now we have the option, right? Because if I want a dictionary, I just need to do that. And now this is a Python dict. If we realize we want to compare the JSON string response, we have it right there. Let me do this real quick with all of our Pokemon as well. And this, I think we're going to be able to use it as a dictionary. I don't want to have to replace all those double quotes. So I'm going to leave that. We're just going to leave that. We're going to leave them both as dictionaries or list of dictionaries. And if we need to cross the string bridge, we will when we come back to it. But we now have good answer data that we can work with and that I can import into my test file. And now we can start writing some tests. And we're going to want to test to get all of our Pokemon, and we're going to want to test to get a Pokemon by name. So let's start by writing a test to get all the Pokemon, because that endpoint only has one endpoint to hit. And here's where things get interesting. If we go to URLs py and we go to our Pokemon app, when we created these paths, we added this argument name that didn't have an immediate application, right? It's not part of the URL, but this is now going to become useful in the test. Because what we're going to do is this. And let's take a quick look at this reverse functions source code. So there's not a lot of really useful stuff in here. But what this does is, as the name hints with reverse, is if we give it a name, it figures out the URL path. It goes in the opposite direction, right? And this is really useful because the full URL path for this is longer. It depends on other URL PYs and it might change. So this name, when we feed it to that reverse function, what reverse returns is API/v1/Pokemon. And I just want to check in with folks and see if that makes sense to everyone, or if people have any questions about what name is doing and what that reverse function is doing. Okay. Oh, Murad, yes, sir.
Yeah, one more time. What's name it down? I'm sorry. I
Yeah.
reversed function.
Absolutely. So we can give our path a name. When we write our test needs to make an HTTP request. It's going here, right? This is the full path. But it's easier rather than typing that in and having to look it up through multiple URLs, PY, and especially if it changes, that reverse function, and let me get rid of this annotation stuff. This reverse function, I give it the name and it returns a URL that goes into the client. Because what self client is doing is making an HTTP GET request to get HTTP localhost 8000 API v1 Pokemon. So it's a helper for us. And I realize we're just a little bit over noon, folks. And we're kind of almost at the finish line here with these tests, because this was sort of the last major concept and setups. And at this point, we're almost at the finish line. So what this client is going to do is it's going to make an HTTP request exactly like Thunder Client. It does exactly what Thunder Client does, or curl, or the browser, and we get an HTTP response back, just like you saw me do in the command line a minute ago, or just like we see in Thunder Client. And now that we've grabbed the correct answer, we can write a test to assert that the answer is indeed what we expect to get. So we need to do a little work with JSON, because the response is going to come back as JSON text. Brandon, yes, sir.
Speaking of making sure the tests work properly, has the curriculum been changed to fix the outdated or the deprecated test cases?
Oh, with like assert underscore or assert equals in those assignments?
Yep.
Yes, it has. And all of them should be fixed. If there's one that's not, let me know and Slack me, and I'll take care of it today.
And I just verified, at least for 1 and 2, I just ran them earlier today, and the first time I ever ran them for the file, and they ran fine. I didn't have any errors. So I think that something was updated and it did fix.
Yeah, I apologize. I didn't get to that sooner. I think it was either Tuesday. I think it was Tuesday or Wednesday. I just went through all of them, and they should all be up to date. That said, a couple solution branches I think are like 1 or 2 versions behind. All the tests are up to date, but I think there may be some additional tests. But all the test code everywhere is correct. I do want to get back to this though, because I don't want to keep people any longer past lunch than we have to. So let's kind of refocus ourselves back on how to write this test. So we get a response back from the client, and it's going to give us JSON. So we need to load it in as JSON. And this, in fact, I believe gets us a Python dict from the JSON. And now we can compare this with our answer. So now we should be able to do self assert equal and compare our correct answer to that response. And let's actually run this test and see if it works. Let me make sure I'm in the right directory. Let me move into the backend directory where manage PY is. And now we should be able to run Python manage PY test. And then I think we have to say tests. Yeah, I think I might just have to be, let's try, I'm pretty sure, Python manage PY test. There we go. So the tests run, but it looks like I have an error in one of my in one of my tests, let's see, failed to import test module, test models, test view, failed to import test module. This might just be, I wonder if this is a pathing thing. Or maybe I'm running the test from the wrong spot. Use a dotted module name or path to a directory instead. So I think I had it right before. I apologize. It just looks like I have an import path wrong at some point that's throwing an error. So I think we're awfully close. Attempted, because I see attempted relative import with no known parent package. And I feel like that should work, but it doesn't want to. I may be getting stuck here. I'm not sure if I want to debug this live. Let's make sure I'm running these tests the right way. And this may be exactly what I'm doing wrong, is maybe it's not directory structure, but it's module name based, which frankly always gets me with Django. And let's see here. There we go. Okay. Yeah, and it looks like the move data fixture may also be an issue. So let's copy that over very quickly from move data fixtures to Pokemon app fixtures. So let me make sure this is working, and then I can explain what I did wrong. Yeah, I apologize, folks. There's something relatively straightforward that I'm getting hung up on here. That's more of like a pathing issue. If anyone sees what it is, please let me know. Otherwise, I think what I will do is debug and make sure that this code is updated and just share the correct steps in Slack, because I don't want to try and debug live. But we kind of saw, I think, the important piece to see here in writing this test. Where we make an HTTP request, we use this reverse to get the path. We get an HTTP response. We grab the JSON from that and turn it into a dictionary. And then when we have correct data, we can run an assertion against that and confirm that our test is correct. And we would do basically the same thing for an individual Pokemon. It would just look like this. Where again, we're going to use the client. We're going to make an HTTP GET request. We're going to use the reverse function. to get the A Pokemon endpoint, and we have to pass a URL param here, right? And we can actually pass that as an argument into the reverse function. And we do this with this argument args that takes a list. And here, let's just pass the Pokemon name. So this could be the ID integer of 1 or the string of the Pokemon name. And then once again, we want to get the body of the response. And we want to make an assertion. And we want to compare the correct answer against our response data. And so then, once I figure out how to make these tests correctly run, with the pathing stuff, we have tests that make actual end-to-end tests. We're making an actual HTTP request to our Django server. And then the Django server is actually querying the database and doing all the stuff we wanted to do and sending an HTTP response back. And then that's what our test is actually testing. There's a little bit more with testing URLs that I was not able to get to today. I think it's been a long day, so I don't want to spend too much time on it. I do want to demonstrate it so we can at least see what it looks like. It is less important. I'd say this is the critically important stuff. And again, I'll follow up pretty quickly after the lecture when I can debug this offline with the correct steps to make these tests run. But let's just take a quick look at how to also test that some URLs are correct. So actually, let's see, we're at 15 after. Yeah, let me show you all this and then we can wrap. So let's make one more file. We'll call it test URLs py. And let me close these other things out. And let's import some of the things that we'll need. We're going to need to import the test case class. We're going to need to import that reverse function, another function called resolve that's going to be quite useful. We're going to need to import from the Pokemon app views, all of our views, our view functions. And I wonder if the issue here is the location of this tests file, in fact. Yeah, you know what, folks? I apologize. This pathing stuff, this is just going to cause more problems. I'll follow up later, I think, with like a clean implementation of this. The critical stuff we've already seen. In terms of testing URLs, I think that the one thing to know is that we can use like resolve and reverse together to test the URL. Let me at least code this out so we can see it actually, and then I'll sort out the squigglies and the other issues later, but let's at least code this out so we can see what this looks like. let's write a test for the URL for the all Pokemon endpoint. And let's actually get the URL. Right, so this will actually get us the URL string. And I believe, let's take a quick look actually at resolve. Yeah, so resolve is going to return something. And I apologize that this code I'm a bit less familiar with. We're going to write 2 tests here though, and then I think we'll circle back and take a quick look at resolve. We want to check that the URL path matches the route. And we want to check that the correct view is associated with this endpoint. So if I wanted to, I could write 2 separate tests for this. Just to demonstrate the technique, I am going to use a feature of the unit test library called subtest. Right, so we're basically doing a test within a test. And we want to do an assertion here. That the URL route is what it should be. And I want to check in just a moment what resolve is returning so we can talk about that properly, but I want to write this code out. So we're checking that this is what we expect it to be, the URL itself. And we're also going to make sure that we're using the right view class with the URL. And so we see that here, I misspoke a little bit. This is not an actual URL string that we're getting right here. So let's take a quick look at the Django docs and confirm what we're getting back. So here's the function that we're using, resolve. As we see here, we do indeed give it a path that we can use reverse to get. And this is where Django starts to get complex. It returns this object call of this class resolver match that lets you access all sorts of metadata that we see happening here and here about the URL, right? And if we dig into this, we see there's a lot of stuff going on, right? We can get the URL name, we can get the function involved, we can get everything related to it. So this is actually sort of object-oriented coding in Spain. So this actually, you know, gets us a resolver match for this path. Right? And I actually think, and this is where this is part of the reality of working with frameworks like Django, is there's a lot of complexity going on here. This is going to be less common in tests. We've really covered the critical stuff, I think, with test views, right? And making an HTTP request and getting a response. But this is good to see as well, to see this resolve step, that we can get this object that has a ton of information about our path, including the URL and the view associated with it. So it is useful to see. And that is the last thing that we want to cover. I appreciate you all sticking around. Once we wrap, I'll kind of debug that issue offline to get the tests running. And then I'll share in Slack and I'll update maybe in our curriculum to make sure that it's really clear where to go to see how to run this test. Because I think I was just having a pathing issue there. Let me go ahead and pause our recording. Let's take a quick look at the assignments and our plan for the rest of the day.